At making this movie, our plan was to merge a Pajero Sport and computer graphics with video footage of real scenes filmed in Los Angeles. We were worried that the CG car might look unnatural when placed against a real background. The old Pajero, which is close in size to Pajero Sport, was selected as the dummy car. Actual Pajero Sport tires and wheels were fitted to the dummy, and filming was undertaken by trying to replace everything with CG of the Pajero Sport with the exception of the tires. The car was covered totally in matte black tape. We wanted to use the cloud of dust overlaying the car body in the off-road driving scenes as texture material later on. For filming, we used a high-vision camera by Sony. For the CG process, we used 3ds Max, and in some parts, Maya. This was all for the purpose of creating photorealistic images. Offline editing was carried out using footage filmed in LA. Being offline, the use of the footage can be determined, which also defines the volume of CG work. The first task was to reproduce the movements of the recording camera and dummy car respectively. To reproduce the movement of the recording camera, we used the Match Move software, Bojo. The actual footage and the filming information recorded during shooting were used to analyze how the high-vision camera moved within a three-dimensional context during the actual shoot. This would work as a base for creating animation of the camera. To reproduce the movements of the dummy car, a CG model of the old Pajero was prepared. As there are differences in body configuration and size between the two cars, the CG model of the old Pajero was used to accurately reproduce the movements of the dummy car and then replaced with the Pajero Sport. Production of the animation was a manual process. Recorded footage shots were placed into 3ds Max as an underlay. The movements of the dummy car and the CG model were overlaid according to the perspective of camera angles analyzed with Bojo. Any unnatural movements were corrected after repeated previews, gradually realizing vehicle movements that match production requirements. The CAD data for the actual car design was converted to enable CG modeling using 3ds Max. The data was optimized so as not to compromise visual integrity. We needed to reproduce a CG model that was no different to the actual car right down to the finest detail. So, where there was insufficient CAD data, the supplementary modeling work was carried out using other materials than CAD data to fill any gaps between the model and the actual car. Lighting and reflections on the car are important for creating depth in vehicle images. In particular, when combining CG with real background footage, the environment surrounding the recorded viewpoint needs to be seen as a reflection. Still shots were therefore taken with the digital camera immediately after filming for use as reflection footage. The images were processed using retouch software to produce reflection footage. The processed reflection footage was loaded into 3ds Max and placed so that it appears to reflect the vehicle's surroundings. Adjusting position and lighting creates vehicle depth. By repeated processing of reflection footage and adjustments of position and lighting, finally, we achieve the depth demanded by production values. To produce the final images, online editing and merging was carried out using real images and the CG vehicle created using 3ds Max. Apart from the merging process, other tasks such as partial corrections of the CG vehicle and removal of any unnecessary elements recorded in the background footage were also carried out. As a general rule, an empty stage with no dummy car is most often used for merging background footage. In this case, however, that would have been difficult. This meant that real footage was utilized for tires on the dummy car and only the body consisted of mostly CG merged cuts. Therefore, footage recorded of the dummy car was used as the basis of the production. And the car parts that protruded when merged with the CG vehicle had to be removed. Based on a total length of 90 seconds, out of a total of 53 cuts, CG processing was carried out on 40 cuts. Personnel were allocated to manage each process, and a photorealistic reproduction of the vehicle was completed within approximately 2 months.
Never turn away. Go straight. All new Pajero Sport.
Drive at Earth Mitsubishi Motors.
Part of the production involved conveying the traveling car pulling along the surrounding landscape. To achieve this, the process of the car making contact with the cloth and pulling it along was physically simulated. Tests were repeated until cloth movement conformed to production requirements. Once the cloth movement was determined, the texture mapping was carried out with retouch software to place the scenery footage onto that cloth. Texture processing created the realism for each cut.